In this video, we're going to talk about finding the equation of the tangent line. So before we look at an example, just remind yourselves what a tangent line is. So if we draw a little Cartesian plane, and then we draw a function, we'll call it f of x. And then if we pick a point, maybe here, call that x, then the tangent line is going to have the same slope as the instantaneous slope of the function at this point. So the tangent line is just going to touch this point like this, and it's going to have the same slope as the instantaneous slope at this point of the function. So this is the tangent line. And a note to make is that the tangent line is not the same as the tangent function. So the tangent line is not the tangent function. They're two different things. So keeping this in mind, let's look at an example. Let's say we're given the function f of x is equal to x squared minus 7x plus 21. And we're asked to find the equation of the tangent line at the point x equals 9. So the first thing we want to do here is we want to find the derivative of the function. So let's go ahead and do that. So the derivative, f prime of x, is going to equal to, we're going to go ahead and use the power rule, so we get 2x minus the derivative of 7x is 7, and the derivative of 21 is just 0. So the derivative is 2x minus 7, and because we know that a tangent line has the same slope as the instantaneous slope of that point in the function, what we want to do is now find the slope of this function at the point x is equal to 9. So here we found a derivative. That is not the slope, but it helps us find the slope, because if we plug in f of 9 into the derivative, then we get 18 minus 7, which is equal to 11. And this is the slope at the point x is equal to 9. So we got our slope. The next thing we want to do is we want to find the point on the function. So we know that x is equal to 9. And if x is equal to 9, what does y equal? Well, if we plug 9 into the original function, then we're going to get y. So f of 9 is going to equal to 9 squared minus 7 times 9 plus 21. And that's going to give us 81 minus 63 plus 21, which is equal to 39. So now that we know the y, we can go ahead and say that the point is 9, 39. So now that we know the slope of the function at x equals 9, and we know the point, we can go ahead and form the equation of the tangent line. So step 3, we're going to use point slope form. Y minus y1 is equal to m times x minus x1. And we're going to go ahead and plug in the y coordinate, the x coordinate, and the slope. And when we do this, we get y minus the y coordinate, 39, is equal to m, which is the slope we found to be 11, times x minus the x coordinate, which is 9. And then we can go ahead and distribute this 11, giving us y minus 39 is equal to 11x minus 99. And then we can add 39 to both sides, which finally gives us y is equal to 11x minus 60. And that's it. This is the equation of the tangent line. And if you wanted to, you could also use y is equal to mx plus b instead of point slope form to find the equation of the tangent line. So we would have to plug in x and y and m, find b, and then replug m and b to give us an equation. But we commonly like to use this equation. Alright, let's look at another example. So this next one, we have the function y is equal to e to the x over x squared. And we want to find the equation of the tangent line at x is equal to 1. So once again, the first thing we want to do is find a derivative. So looking at this, we see that we're going to use the quotient rule to get the derivative. So we get low times derivative of e to the x is e to the x minus high d low, the derivative of x squared is 2x. Bottom squared, 2x to the second power is the same thing as x to the 2 times 2, which is x to the 4th. And off we go. So now we see that we can factor out an e to the x, which will give us e to the x times x squared minus 2x over x to the 4th. And this is y prime. And then we'll go ahead and also factor out an x, which will give us e to the x times x minus 2 divided by x to the 4th. We'll go ahead and cancel one x out, giving us a 3 here, which finally gives us a derivative of e to the x times x minus 2 over x to the 3rd. So now that we got the derivative, this will help us find the slope, or the instantaneous slope, at x is equal to 1. So we'll go ahead and plug in 1 for all the x's to get our slope. So doing that, we're going to get e to the 1st times 1 minus 2 over 1 to the 3rd, which is the same thing as e times negative 1 divided by 1, which is just negative e. So here we got our slope. So now we'll go ahead and identify the point. So we're given that x is equal to 1. And then from that we can find y if we plug it into the original function. So y is going to equal to e to the 1st over 1 squared, which is just e. So y is equal to e, so therefore our point is 1e. So now we see that we have our slope and we have our point, so we can go ahead and form the equation. So we'll go ahead and use point-slope formula, which will give us y minus e is equal to negative e times x minus 1. We'll distribute this negative e, which will give us y minus e is equal to negative ex plus e. And then we'll go ahead and add an e to both sides, finally giving us e is equal to negative ex plus 2e. And that's it. So now let's look at a couple other problems that you guys will probably run into. So let's say we have the equation y is equal to 2x to the 4th minus 8x to the 3rd minus 16x squared plus 9. And this time we're asked to find all the places where this function has horizontal tangent lines. So where does it have horizontal tangent lines? So our horizontal tangent line will look something like this. If we have a wavy function, then it'll just touch a peak and it'll look something like that. And then we can see here that a horizontal tangent line has a slope of 0. So what we want to find is we want to take the derivative of this function, and then we want to see where does the slope equal 0. So we'll go ahead and take the derivative. So y prime is equal to We'll go ahead and apply the power rule to each term. So we get 8x to the third minus 24x squared minus 32x, and then the derivative of any constant is 0. So here we have the derivative, and now we want to find where does y prime equal 0. So where does the slope equal 0? Because then that will mean that we have a horizontal tangent line at that point. So we'll go ahead and set this derivative equal to 0. So we have 0 is equal to 8x to the third minus 24x squared minus 32x. And then we'll want to start factoring, so we see that we can factor out an 8x. 0 is equal to 8x times x squared minus 3x minus 4. And then we can further factor this by factoring this quadratic. So we want to find something that multiplies to -4 and adds up to -3. That'll be -4 and +1. So we get 0 is equal to 8x times x minus 4 times x plus 1. And then setting each term equal to 0, we'll finally get x is equal to 0, +4, and -1. So at x is equal to 0, 4, and -1, we have a horizontal tangent line. Alright, let's take a look at another one you might run into. So here we're given the function y is equal to e to the x, and we're asked to find where is the tangent line parallel to the line y is equal to 3x minus 17. So if we know that if something is parallel, that means they look something like this and they have the same slope. So for the tangent line to be parallel to this line, then we know that the slope has to equal to this line slope, which is 3. So we want a slope of 3. We'll go ahead and take the derivative of this function, and then we'll set the derivative equal to 3, and then we'll see which x's give us the slope. So let's go ahead and do that. So the derivative y prime is going to equal to, well, we know that the derivative of e to the x is e to the x. And now we want to find where the slope is equal to 3. So we'll go ahead and set y prime equal to 3, giving us 3 is equal to e to the x. And now we want to isolate the x, and we can do that by taking the natural log of both sides. So we get the natural log of 3 is equal to the natural log of e to the x. And then we know that if we have a power inside a natural log, we could go ahead and bring it out in front, which will give us the natural log of 3 is equal to x times the natural log of e. And we know the natural log of e is equal to 1. So we finally get x is equal to the natural log of 3. So this tells us that when x is equal to the natural log of 3, then we have a tangent line that is parallel to this line.